On this EOC linear review, the first question we're doing is a same position question. A lot of questions say same position. Usually, if they give you two equations, you just make both equations equal to each other, and you solve it. Here we don't got an equation. We could create an equation for both, but that's a whole lot of work that I don't recommend you do. This is what I recommend you do, okay? Now, before I show you what to do, which is extend this table, let's look at the patterns here. X, this X value belongs to both sides. So 0, 0.0, 0, 0.0. The first point for the F equation is 0, 0.0, comma, negative 9. What's the first point for the G? 0, 0.0, comma, 19. So that's where you get points from a table. This is your X, this is your Y for the F. This is your X, this is your Y for the G. You with me? So instead of putting two separate tables with the same X values and then separating them, they put them all together in one. Now, this is all I want you to do. Follow the pattern and extend this table further until both Y values are the same. So watch, let's continue the pattern all the way to 5 seconds. So over here on the second side, what's the pattern? How much is it going up by? On the X values, what is the pattern? How much is it going up by? 0.5. You're thinking about f of x, George. Not yet. We're looking at the x column. So after 2.5 seconds, half a second more would be 3.0. Half a second more, 3.5. Follow that pattern all the way to 5 seconds. Pretty simple. Just follow the pattern. Now let's do the same thing for the middle column. The middle column, like George said, is going up by 3. 0, 3, 6. What's the next number if you're going up by 3? 9, 12, 15, 18, 21. Up by 3. 3, 3, 3, 3. Easy so far? Now, on the g of x, it's going down by how much? Down by 1. So the next number is 13, 12, 11, 10, 9. Now, at what point are both values the same? 12. What is the x value for 12? 3.5 seconds. That's your answer. After how many seconds are they the same? Right? Same position, same. You with me? Pretty simple? Now, the main thing on this lesson is graphing. So now we're going to start graphing. As usual, I'm going to guide you through some. So up here it says guided. This one says Oyo. You're going to have a bunch of practice problems to do, but on your own. But first, we're going to do the guided questions. Okay? Now, this is stuff you've done before, so hopefully you remember it. If not, it's okay as long as you remember, you learn it right now. All right, so let's start off by reading over here the steps. Over here, when you graph, the method or the format that you want the equation is, for the most part, is slope-intercept form. It doesn't have to be that way, but I think that's the easiest way to graph, and you're going to see why in a minute. So slope-intercept form, which just means get the y by itself. Now, the steps to actually graphing it, once you have it in slope-intercept form, are these two simple steps. The last one says draw a line. That's not considered a step because that's what you're going to do anyways. So two simple steps. Plot the y-intercept, which is b, that number, and use the slope to rise and run from that point that you made. Once you have those 2 points, you draw a line and you're done. So look over here to the first equation. The y-intercept is the constant, the number that has no variable attached to it. So the y-intercept is -4. So right on the y-axis, put a dot on -4. And now the slope is 2 over 3. It's the rise on top, the run on the bottom. So it's going to be up 2, right 3. Up 2, right 3. Done. Once you have 2 dots, you can draw a line. We just graphed a line. Now, look at the one you're doing on your own. The negative is on the 3, which means instead of going up and right, you're going to go down and right. So do the same steps right here. Graph the y-intercept, down 3, right 4. If you're not done, you're probably overthinking it because it's very simple. The constant is a number that has no variable. Is y by itself here? Yes. So we can already read this as the y-intercept, +2. And now the slope. Let me be clear about the slope. Even if the negative is next to the fraction like this, it's your job to put it somewhere. You have to put it on the top or on the bottom. For this class, I always recommend you put it on top. That's why I put it on top of my problem. So always put this on top. It can't stay next to the fraction because you won't know what direction to move, up or down. So now, over here, we go down 3, right 4. -3 is down 3, +4 is right 4. Now you can draw your line. Simple? All right, now on the next page, very, very important. So please pay close attention to this next page. This is a question that usually gets skipped because they think they can't do it. The student thinks that it's more complicated because it's a decimal. So watch over here. First one is a guided example. The next two you're going to do on your own. So look at this first one. There is many ways to graph this, right? One way is create a little table. Don't write this down, guys. Don't write it. But you could create a little table with any x values you want here, plug them in and solve. So like 2.5 times 0 minus 3 is -3. 2.5 times 1 minus 3 is -0.5. So on and so forth. And you can plot a bunch of points and draw your line. But that leads to more mistakes. It's easier to learn one method of graphing, which is the one we just practiced last page, and use that one every time. So watch. 2.5 is 2.5, correct? How do you make that into an improper fraction? By multiplying and adding here. 2 times 2 is 4, plus 1 is 5. So this is 5 over 2. Calculator does this for you. You could put 2.5, press the fraction button, and it'll turn it into a fraction. So if you don't know how to do it like this, then just touch the button on the calculator. Now we can graph this just like we did the other page. What's my y-intercept? -3. So we mark -3. Now the slope is 5 over 2. That would be up 5, right 2. Once you have 2 dots, you're done. Draw your line. Straighter than mine. Any questions? You guys understand that? All right, try the next two on your own. 1.5 is what as a fraction? 1.5 and 3.5. What is that going to be as a fraction? Improper fraction. 3 over 2, very good. And this one? 7 over 2, very good. Now you know which directions you're going to move. Up 7, right 2, up 3, right 2. Go ahead and do it the same way you did the previous page. So on the second example, we changed 1.5 to 3 over 2. So now we get to graph it using the slope-intercept method. Positive 2 is your y-intercept. You put your first dot right on the y-axis. And now from that dot, not from the 0, from that dot, you go up 3, right 2. Done. Now on the next one, same thing. Negative 3 is the y-intercept, so we're marking negative 3 right here on the y-axis. And then you're going to go up 7, right 2. So up 7, right 2 lands right here. Done. Now, you can always double check your answer. If your slope is positive, this should be going up from left to right. You see that? If the slope is negative, it goes down from left to right. So you can always verify part of your answer that way. Any questions on graphing decimal equations? All right, let's move on to the next part here. On this next page, all these questions are not in slope-intercept form, right? So I'm going to show you again how to get it into slope-intercept form on the first question. Then you're going to do the next two on your own. Remember this. Don't go ahead because this is so simple that you need to see me do it once and you're good. 2 steps. Take away the x term and divide by the y. That's it on all 3 of these. So what's the x term here? X. How do you take away an x? Minus x. Clear? Now we bring down negative 1y equals negative x minus 3 because those two can't be put together. They're not like terms. And now you just divide by the coefficient on the y. Divide by negative 1, all 3 terms. Now we have an equation we can graph. Y equals negative 1 divided by negative 1 is positive 1. So this is positive 1x. Negative 3 divided by negative 1, positive 3. Now we can graph it. Positive 3 is the y-intercept. If you don't see a number on the x, what's the number there? 1 over 1. So you're going to go up 1, right 1. Done. Pretty simple. It's the same steps, except here you have to get the y by itself first using these 2 steps. Take away the x. So over here, the 2 steps, I'm going to say them out loud already. Minus 2x and divide by 3. Right? Look at over here. What are the steps? Minus x and divide by what? Negative 2. That's it. Those are the only 2 steps. So go ahead and try that on your own. These 2 are OYO questions. So on the first example you're doing on your own here, the 2 steps, like I said, simple ones. Take away the x, so you're doing minus 2x on both sides. Now, when you bring down what's left, make sure you bring it down in the right order. Don't write the 12 first. Even though the 12's first up here, it doesn't have to be the first thing down here. Write it in the correct order. Put the x term first. So minus 2x, because that's a negative 2x, and plus 12, because that's a positive 12. Now you just divide all 3 terms by 3. Now that gives you the equation that you can graph. Y equals negative 2 over 3x plus 4. Now let's graph it. The y-intercept first. Positive 4 is the constant. That's your y-intercept. So mark positive 4. And now use the slope to rise and run. Negative 2, would that be up 2 or down 2? Down 2. So we're going down 2, right 3. And we're done graphing because we have 2 points. Now this next question tends to confuse people because there are imaginary ones there, but it's the same process. You're going to do minus x on both sides. That leaves you with negative 2y equals negative x plus 6. And now you're dividing everything by negative 2. Now here it goes. A negative divided by a negative is a positive. So that's positive 1 over 2. That's usually where the mistake happens because of that imaginary 1, or they leave the negatives. 6 divided by negative 2, negative 3. Now we have something we can graph. First dot goes on negative 3 because that is your y-intercept. And now the slope is 1 over 2, so we go up 1, right 2. Up 1, right 2. Copy down the work, and then we'll move. Now, notice the difference between what we've done so far and what we're about to do here. Okay? These are inequalities, not equations. Don't worry, you do them the same way. So let me write down 2 little quick notes here that are all you have to think about when you do this. When you have a greater than or a less than symbol without the little line underneath, then your line has to be dashed. So whenever you draw your line, make sure it's dashed. Like instead of just drawing a line, draw a dashed line. There's a reason for it. You'll see me do it now. Don't worry. Right? That's the first thing you have to consider. And the next thing you have to consider, this is super important. Most people don't know how to read inequalities. Okay? Open to the y means greater than. Closed to the y means less than. So you have to look at how it faces the y, now how it faces the x. You understand? The letter you're getting by itself is y here, right? So you have to look at how it faces the y. That way, this way doesn't work once you pass elementary school. You have to see how it faces the variable in question, which in this case is y. So is this open or closed to the variable? To the y? Open. That means that we're going to shade above because this is greater. So you shade above. If it's less than, you shade below. So watch me graph this. Same thing we did before. Negative 3 is your y-intercept. So we mark negative 3. And now your slope is 2 over 1. So that would be up 2, right 1. Same thing. Everybody with me? Now, when you go draw the line, because it doesn't have the little equal to symbol underneath the inequality, make it dashed. A dashed line, not solid. So far, so good? Now, you guys said it's open to the variable, which means greater. If I say greater, are you going to shade above something or below something? Above. So we shade above that line and we're done. Yes, but it's one click on the computer on the EOC. You don't have to like drag your mouse and do that. It's going to let you click either here or here. And as soon as you click it, it'll shade the whole thing. You with me? Like on IXL. Leave them there. Leave them there. Can you not go over there anymore? Stay in class, please. Can you not move from that chair again? All right, this next one, I want you to do it exactly the same on your own, except the line's going to be solid because it has a little equal to symbol, so you don't have to dash it. And then shade it either above or below, depending on how that faces. Yes. Yeah, it's always going to be shaded. What? With inequalities. You only have to shade with inequalities because it's a whole region that's a solution. Remember, you're not doing both questions. Just do the center one. Leave the other one for me to go through it with you because the other one is the one exception, the one difference between solving equations and inequalities. Flipping the inequality symbol here. So don't do it. Save that for a guided example. So pay attention here. Positive 2 is the y-intercept, so we mark positive 2. Now the slope is negative 2 over 1. Down 2, right 1. Now, Is it open or, oh, I've made the line solid because it has the equal to line here. That's why it's not dashed like the first one. Now, if I look at this, it's close to the y. That means it's less than. So we need to shade below this line. When the line's like this, or even flatter, it's easy to see what below is. Below is right here, below that line. But I'm about to show you a trick. Okay, so copy down that graph, and then let me show you the trick. I'm going to erase the line that is there so I can show you the trick. So pay attention here. So it's easy to see what above and below something is when the line's kind of flat. But when the line is tall like this, almost straight up and down, or like this, it's harder to see what above and below is. Here, probably easier because this is a positive slope. But on the negative slope is where usually the confusion happens. So watch my trick, okay? This is my trick. I've taught it for years. It works. So this is your pencil, right? Put your pencil on the line. What's the closest way to make this horizontal? To the left or to the right? Let my students answer, please. So we have it on the line. What's the closest way to make it like this, perfectly flat? Left, right? Left. So watch. We go to the left and make it flat. Now put your hand where below would be, because we're gonna shade below this. Right here is below this graph, right? Now put it back to where it was. Wherever your hand is, you shade. So look over here. Let's say I'm gonna shade below again. What's the closest way to make this horizontal, right or left? Right. So we put it right. Below is down here. Put it back to where it was. Where's my hand? Over here. I shade here. So you only need that trick when it's like almost standing up. Or you could just remember, below on a negative line is the left side. Below on a positive slope is the right side. But that's harder to memorize than the little pencil trick. Okay? So now that I taught you that shading trick, let's go on to number 3 here. Now, on number 3, this is the one difference between solving equations and inequalities, the flipping of the inequality symbol, which is going to happen here. So, same 2 steps. Subtract 3x from both sides. Then you're going to divide by the coefficient. But let's bring everything down first. Negative 2y is greater than or equal to negative 3x plus 6. Now, last step is dividing always. So we're dividing by negative 2. If you do it to one side, you do it to the other, all 3 terms. Now, stop right there. This is the point where if you ever divide both sides by a negative, grab that inequality symbol and flip it around. So instead of being open to the y, now it's going to be close to the y. You with me? Now let's put the result up there. Negative 3 over negative 2. A negative divided by a negative is a positive. So we have positive 3 over 2x. And then 6 divided by negative 2 is negative 3. Now that's something we can graph. Negative 3 is the y-intercept. Up 3, right 2. Now, since it has the little line, it's a regular solid line, not dashed. Now, is it open or closed to the variable, to the y variable? Is it open or closed to the y? Look up here, not at the original spot. Your final answer, is it open or closed to the y? It's close to the y, right? It's pointy to the y. That's what I mean by closed. Open would be like the alligator eating it, like you learned in elementary. So it's close to the y, which means less than. So are we going to shade above or below? If I say the word less than, below. So if we shade below this, it'd be this whole area. Above would be here. Any questions before we move on? All right, on the next section, we're going to start with transformations. So it's not that many pages, but make sure you write the rules again. What we're going to work on is only vertical and horizontal for this review. Only vertical and horizontal. So go ahead and copy these notes and I'll explain them to you in a couple. So on this part, we're going to review transformations, which is just moving a line from one place to another place. Okay? Sometimes it'll be a vertical movement. Vertical goes in two directions, up and down. Sometimes it'll be a horizontal movement, which means right or left. And sometimes it'll be a combination like you did in the worksheets throughout this year, where it'll say up 3 and 4 right. It'll have both movements. So I want you to main thing here is I want you to see the parent function here. See the parent rule and look at where the k value is. K is just the amount of units. So if I say 4 up, what's k? Positive 4. If I say 4 down, what's k? Negative 4. You with me? So that's why I wrote it here. If k is positive, you go up. If k is negative, you go down. So main thing, not in the parentheses versus in the parentheses. Now, vertical, super normal. Up is positive. You could have guessed that because that's how it usually works. Up is positive. But the horizontal side is always backwards because the formula has a minus in it. Now, I always use the plus there to avoid confusion, but all you have to remember is that if k is positive and it's in the parentheses, you're going left. That's backwards because usually we're the positive numbers to the right. So be careful with that. Don't invert that by mistake. So if k is in there and it's positive, you go left. If k is in there and it's negative, right is the movement. So far, so good? So let's just label a couple. F of x minus 2. How many units where is that? 2 down. Very good. How about f of x plus 6 in the parentheses? What is that? 6 to the left. Very good. So that's all you have to remember, right? A positive is left. How much? That number. A negative out here is down. Any questions? Pretty simple. You've done this before. We did this, I believe, when I was in the other classroom, using another room because they were doing some assessment. All right. Now, here we go. These both are guided examples. As you can see on the next page, you got OYO examples. So don't do any of these on your own. We're going to walk through this together, and you're going to do the same steps on the next page for your OYO questions. Okay? So here, blue is the original. That just reminded me, I have to change the worksheet because I didn't print it in color, and I have blue and red, which are both going to be black on the worksheet. So I'm going to change that from blue red to like darker line, lighter, something like that. All right, so let's do this. In the vertical transformation, provide the movement, the rule, and the K value. So what do I mean by movement? How many units where? That's what I mean by movement. So you're going to put 2 units up, 3 units right, something like that. Okay? So blue line is the original. Let's mark a point on the blue line. Any point you want. And now, go see where they moved to create the red line, because the red is a new line. So did they go up or down to get to the red line? Down how many units? 3, 4, 5, 6. Down 6 units. So here on movement, you're going to put down 6. On the rule, what is the rule for down 6? F of x minus 6. Because it's down. So same thing you saw on this page. Down is negative. So if it was down, you put minus. And now the K value, negative 6, is right there. Simple? Let's try the next one. Now here, like I said, I put vertical here for a reason, okay? Vertical means up or down. Look at this one. It's vertical again. We're going to do vertical first, then horizontal. Why am I doing vertical first? Because sometimes you can go up a certain amount of units, and also if you would have gone right 3, it gets you to the red line also, or left or whatever. So sometimes you can do either one, up or down or right or left. So they're always going to specify vertical or horizontal to tell you which one to use. You with me? So both of these examples are up or down. We're not thinking right or left on any of these next 4 examples. So over here, original line is the blue line. Mark a point on it, any point you want. So I'm going to mark the y-intercept. That's usually the easiest one to mark. And now, do we go up or down to get to the red line? Up how many boxes? 1, 2, 3, 4, 5, 6, 7. Up 7. So the movement is up 7. What is the rule for vertical transformation? F of x, and outside the parentheses, plus 7. What is the k value? 7. You with me? Pretty simple. This is the worksheet you guys did pretty quickly in class, just the labeling part. So on this next page, OYO questions, 2 of them, vertical as well. Go ahead and try it. Let's review these examples. So on the first OYO question, here, wait, let me let this person in real quick. All right, on the first OYO question, in the vertical transformation, provide the movement. So we're going from blue to red. From blue to red is up. Up how many boxes? 1, 2, 3, 4, 5, 6, 7. Up 7 boxes. So the movement is up 7 units. The rule is f of x plus 7 because up is positive and vertical, the number is not in the parentheses. And then the k value is 7. On the next example, say no te escucho. Okay. In the vertical transformation, provide the movement. We're going from blue to red again. How many units? 12. From here to here is 4. From here to here is 8. So that's 12. So here we go. Down 12. There's the movement. The rule is f of x minus 12. The k value, negative 12. Simple? I'm telling you, if you guys can do this again on the standardized exam, there's none of these questions you're going to get wrong. This is all you really have to be able to do. Label them and write down the rules for them and the K values. All right, on the next page, these are going to be horizontal ones. So we're going to work on these together. Again, on the next screen, 2 OYO examples for you to do on your own. So over here, let's do it. We're thinking now horizontally. Horizontally is only right or left, so we're not thinking up or down anymore. So over here, from the blue line to the red line, is it left or right? Left 3 units. So here, left 3. What? Yes. So now here on the rule, f of x plus 3 because left is positive, and then the k value is positive 3. The number you're looking at. That's it. No, uh, because horizontal is always the opposite. In horizontal, positive is left, negative is right. You with me? That's one thing you can't forget because the horizontal has a negative as part of the formula itself, as part of the rule. So it changes it to backwards. So all you got to remember is left is positive, right is negative, and that's it for horizontal. Now, on the next example here, let's do it. From blue to red, how many units in what direction? It's to the right, and it's 6 boxes, 6 units. So here we're going to go 6 right or right 6. The rule, it goes in the parentheses because it's horizontal. So it's going to be x minus 6 because right is negative. And now here, k value, negative 6. Easy enough? All right, try these next on your own questions. Same exact process, horizontal on both. So on the first OYO question, in the horizontal transformation, provide the movement. So from blue to red, you have to go to the left. So this is going to be left 7. 7 units. Now the rule for left 7 is f of, and in the parentheses, x plus 7 because left is positive. And now you know the k value is right there looking at you, positive 7. On the second example, the movement from blue to red is simply 2 units to the right. So here we put 2 to the right. The rule for 2 to the right is f of x minus 2 in the parentheses because right is negative. And now the k value is negative 2. So far, so good. Now, before I let you leave, let me show you your worksheet that's coming on Monday. And I want to walk you through some of those questions at the end. This is the follow the pattern questions. I put 3 on the front, the graphing questions below, and this is the part I wanted to show you, the transformation side of things. This part we just did, so you should be able to see from how many units from this line to that line. So that's easy to do. Blank units to the, so here you put 2 units to the right, 2 to the left, whatever. So now look here. This is the one I want to explain to you. Right? This is an old question from these study guides that we used to get from the district. Okay? Let me be able to write on that. Okay. So over here on part A, this is the original equation. It tells you y equals f of x. That's like the original, right? So we're trying to see where this u here moves or how it changed from original spot to where you're looking at it now. So first of all, the first thing you should look at is the shape and size of the U. Did the U get into a different shape? Is it thinner? Is it wider or more narrow? It looks the same, right? So it didn't get wider or more narrow. On the second example, this one's wider than this one. You see it? So it looks like it got kind of skinnier. So these two things are what you're going to be looking at to pick the right answer choice. So let's do the first one. Where's the vertex of the original? Right here on this spot. You see that? Now, where did they move it? Did they move it right or left? Question. It's a yes or no question. Did they move it to the right or to the left? No, they did not because the middle of the U is still on one. So they didn't move it to the right or left, right? So what should go in here for right or left? 0, because they didn't move it to the right or left. So you already know that C and D can't be answer choices because it did not move 1 to the left or 1 to the right. It moved 0 to the left or right. It didn't move to the left or right. You with me? And now, down 1 unit. Which one shows down 1 unit? -1. A is the answer. You with me? So this is one of the concepts you have to remember when you're answering these types of questions. And then the last one here I wanted to review. Remember what I told you. The bigger number, the bigger value of A, so in this case A is 1, so it would be something like this, right? But then let's say that 1 is now 20x squared, right? The bigger the number in the front, the A value, the skinnier the graph gets. Are you with me? So if this was a 1, it'd be wide. If it was a 20, it'd be skinny. Did this graph get skinnier or wider? Skinnier, which means the number got bigger. How would the number get bigger? By multiplying it by a half or multiplying it by 2? By 2. If you multiply something by a half, does it get bigger or smaller? It gets smaller. So in this case, look over here. Let's think about the movements first. From here to here, it's the same exact spot. They didn't move it. They didn't move it right or left, and they didn't move it up or down. The only thing they did was make it skinnier. So which one has 0 on both spots? A and B. It didn't move left or right, so both have to be zeros. Now, which one makes the graph skinnier? Multiplying it by a half or multiplying it by 2? Multiplying it by 2. You with me? So simple things to get right. Like I said, as long as you remember that left or right goes in the parentheses and up or down goes outside. Clear?